This video is going to be about alkenes and the bonding involved in alkenes and what each bond, such as sigma and pi, actually are. So first of all, we'll just look at the simple structure of an alkene. An alkene contains a carbon-carbon double bond, and when you name the compound, it has the suffix ene or ene, such as propene. Now if we look at the bonding involved, there's two bonds, so carbon-carbon double bond. One is known as a sigma, given the symbol of sigma. One is known as a pi bond, given the symbol pi. First of all, if we look at the sigma bond, so the sigma bond is an overlap of the hybrid orbitals of carbon, which if you don't know what hybrid orbitals are, I've done a video on this, so please look at my channel. And there's a shared pair of electrons in this molecular orbital. So a sigma bond, how do you define something as a sigma bond? Well, if we took two s orbitals, for example, say dihydrogen, and there's a sigma bond in there, if we were to put a line through it, going from left to right, if we were to then rotate it by 90 degrees, so we're looking at it like this, with that dot in the center representing that line there, and through it, if we were to rotate it, take a point, and we rotated it at any angle, let's just say 120 degrees, then the image that would get is the exact same one. It would look identical. And that's what a sigma bond is. If you take a line through the bond and you rotate it and it looks exactly the same, that's a sigma bond. And you get the same with hybrid orbitals, such as sp2 in this case. And the other bond type is pi. Now let's look at pi. So pi bond is formed from p orbitals that are overlapping. So the second bond is a pi bond, and these are just showing the orbitals, the two p orbitals involved, and this is what it looks like when you have the electron density when they overlap. Now, a pi bond does not have the same rotation as a sigma bond. If you were to draw a line through this bond, then when you looked at it side on, you would have kind of two circles like this, with a node being in the middle, which a node is where there's a 0% likelihood of an electron being found, where the atoms are. Now if we look at that, if we rotate it, the only option we have is to rotate 180 degrees. And well, we can't do it by 90 degrees or anything like that. If not, it's not going to be the same bond. You have to rotate it so the same image is brought on after the rotation. So that's actually how we get E and Z isomers. So there will be a video later on at some point on E and Z isomers, and if not, you can look in your textbook and read about E and Z isomers, because it's restricted to a 180 degrees rotation, which actually takes a lot of energy to do. Going back to the sigma bonds, this is why we get conformational isomers, because we have technically infinity rotation, and a conformational isomer is where these carbon-carbon single bonds or two single bonds rotate to get the maximum distance between the opposite groups. So if we have CH3 like this and another CH3 group on the other side, then this carbon-carbon single bond can actually rotate around itself so that these hydrogens here and the other hydrogens relative to each other are the maximum distance away. Because if you have them straight next to each other, say there was one unit between there, whereas if you have it off at a slight angle and one there, then it's something, say 1.2 units away, so it's slightly further away, minimizing electron repulsion. That's what conformational changes are through sigma bonds. Like I said, pi bonds can only do 180 degrees rotation, so you get E and Z isomers. Bond angles. If we look at alkenes, we have different bond angles because alkenes have sp2. This is because you have a hybrid orbital going from the carbon to carbon, a hybrid orbital going to carbon to hydrogen, and another hybrid orbital going to carbon and hydrogen, while you have p orbitals on the two carbons. If you don't know what hybrid orbitals are, there's a video on hybrid orbitals that I've made earlier. So we have three bonds making up three parts. So you've got 1 part S character and 2 parts P character. That's all on this video. Thank you for watching. Please like, share and subscribe. Let me know if there's any topics you would like me to cover. Thank you.